Welcome to Talk Tensors, where we unpack the most impactful machine learning research. Today, we're diving deep into a new paper introducing Cerebrum, an AIOS SDK.
That's right.
And now, this isn't just another library. It's aiming to be a full platform, designed to standardize how we build, share, and deploy these autonomous agents, the ones powered by large language models.
Yeah, it's a really interesting development. You could think of it as trying to bring some order, maybe some collaboration to a field that's, well, it's booming, but it's also a bit chaotic right now.
Like the Wild West, maybe?
That's a pretty good analogy, actually. The paper, Cerebrum, AIOS SDK, a platform for agent development, deployment, distribution, and discovery, it really gets to the heart of a core challenge.
Which is?
Well, we've seen these LLM agents evolve incredibly quickly, right? From just predicting text to doing complex things, browsing the web, simulating social dynamics, making decisions.
Yeah, the capabilities are expanding fast.
Exactly. But that speed has created this gap. We lack shared tools, common standards, and that's actually slowing down progress, hindering collaboration.
Okay, so Cerebrum steps in to try and fix that. Provide a unified approach.
Precisely. It's tackling that lack of standardization head on. The core insight is that this fragmentation is becoming a real bottleneck.
Makes sense. People probably reinventing the wheel all over the place.
That's exactly it. Researchers, developers, they're building similar components in isolation. Cerebrum offers a common framework, a shared space to kind of pool efforts and build on each other's work.
So a bit like what GitHub did for software development, fostering that collaborative spirit.
That's a great comparison, accelerating innovation through standardization and sharing. That seems to be the goal.
Okay, so what are the main building blocks of this Cerebrum platform? What does it actually offer?
The paper breaks it down into three main parts. First, there's the agent SDK itself.
The software development kit.
Right. And it's not just a random toolkit. It's designed with this modular 4-layer architecture. Think of it like, well, you said Lego bricks earlier. That's not a bad way to put it. Each layer handles something specific.
Okay, what are the layers?
So at the bottom, you have the LLM layer. This handles all the communication with the actual language models, OpenAI, Anthropic, whoever.
Makes sense. You need that interface.
Then there's the memory layer. Super important for agents to remember past interactions, maintain context, keep track of state.
Right, otherwise they're just stateless chatbots.
Exactly. Above that is the storage layer. This is for long-term persistence. Think databases, vector stores for knowledge retrieval, that kind of thing.
Okay, LLM, memory, storage. What's the fourth?
The tool layer. This is how agents can use external capabilities, call an API, use a calculator, browse the web. Managing those tools, their inputs, outputs, errors, it's complex.
Definitely. That layered structure sounds logical for managing all that complexity. What about the other two main components you mentioned?
The second one is the Agent Hub. This is conceived as a community repository. Think Hugging Faces Hub, but specifically for these Cerebrum agents.
Ah, so a place to share and discover agents.
Precisely.
Yeah.
And crucially, it includes features like version control and dependency management.
Oh, that's huge.
Isn't it? It means if you grab an agent from the hub, you know exactly what version it is, what other bits it needs to run. It tackles that reproducibility problem.
Yeah, trying to run someone else's code without clear dependencies is painful. Okay, so SDK, hub, and the third piece.
The third is an interactive web interface, basically a user-friendly way to test and evaluate agents right in your browser.
Oh, cool. So you can chat with an agent hosted on the hub.
Exactly. Get a feel for how it works without needing to set up anything locally or write any code yourself.
So the big picture here is moving away from isolated efforts towards a more unified, collaborative ecosystem for building these LLM agents.
That's the core idea. The authors are arguing that Cerebrum provides the necessary scaffolding, the structure, the tools, the sharing platform to really accelerate research and make these powerful agents more accessible and reliable for everyone.
And that layered design isn't just neat, it helps with development speed too.
Yeah, because you can improve, say, the memory layer without having to rework how tools are handled, or vice versa.
Yeah.
It allows for independent evolution of these key agent parts.
Okay, let's dig into the paper itself a bit more formally. How do the authors set the stage in the introduction?
They really start by emphasizing the transformative potential of these LLM agents. They give concrete examples of real-world uses, emerging web navigation, social simulation, complex decision support, things that go way beyond simple text generation.
Setting up the why this matters.
Exactly. They highlight how these agents can plan, reason, use tools, act autonomously. It's a big leap. Then they clearly state the problem Cerebrum addresses. That lack of a cohesive platform is holding things back.
And introduce Cerebrum as a solution.
Right. As both the SDK and the Agent Hub, designed to standardize the whole lifecycle building, running, deploying, sharing, and finding these agents and their components.
Do they mention specific agent techniques?
They do. They specifically note that Cerebrum includes optimized implementations of popular methods like chain of thought, Hu2, and React.
Okay, so it's not just infrastructure. It includes some standard agent blueprints, too.
Yes, which lowers the barrier to entry. And they provide links right away to a live demo website, the GitHub repository, even a video demo. They want people to see it in action.
Good approach. After setting the stage, how do they position Cerebrum relative to previous work?
They give some important historical context. They touch on the long history of AI agents as this grand goal for achieving artificial general intelligence. It reminds you this isn't totally new.
But LLMs changed the game.
Massively. That's the key point they make. LLMs have unlocked potential that just wasn't feasible before. They draw a really clear line between older, more static prompt-based interactions and the dynamic, almost independent decision-making these new agents can do.
It's a paradigm shift. From fixed instructions to something more adaptive.
Exactly. It's evolution in AI interaction.
Okay, so let's get into the nuts and bolts. The Cerebrum library design, you mentioned the modularity.
Yes, they really emphasize that. And this dual architecture idea, the layered system for putting agents together, and then a client interface for talking to the underlying AIOS kernel.
The kernel being the engine driving it all.
Kinda, yeah. It manages the core processes. So let's revisit those 4 layers in a bit more detail.
Okay, layer 1. LLM.
Right. Flexibility is key here. Makes it easy to swap LLM providers, OpenAI, Anthropic, maybe open source models. It also gives you smart defaults for parameters like temperature, resource use.
But you can still tweak them if needed.
Oh yeah, fine-grained control is available for advanced users. Then the memory layer. This is all about context and state.
Keeping track of the conversation, the agent's internal state.
Exactly, and its configurable memory limits, how it decides what to forget. They mention using an LRUK eviction strategy.
LLUK.
Yeah, it's a smart caching algorithm. Basically, it prioritizes keeping information that's been used both recently and frequently, which is often more effective than just keeping the most recent stuff. Helps the agent manage its limited focus.
Clever. Efficient memory management is crucial for longer interactions. What about more permanent knowledge?
That's the storage layer. This lets agents store and retrieve data persistently. It supports standard file structures, but also, very importantly, vector databases.
For similarity search and knowledge retrieval.
Exactly. Essential for agents that need to access large knowledge bases. And again, it's configurable. You can choose embedding models, indexing methods, tailor it to your agent's needs.
So you've got short-term working memory and long-term persistent storage. Makes sense. And the tool layer.
This manages integrating and using external tools. It handles discovering the right tool, loading it, validating its parameters, running it, and crucially, dealing with errors if the tool fails.
That seems like a complex but vital piece.
It really is. And for the real power users, there's an optional overrides layer. This lets you tweak low-level AIOS kernel settings, like the scheduler, for very specialized tasks, while trying to maintain overall system stability.
Wow, okay. That's a comprehensive set of layers. But how does Cerebrum manage all these agents and tools being created and shared?
That's where the Manager module comes in. It's the orchestrator. It handles the lifecycle management for both agents and tools.
So things like distribution, version control.
Exactly. Distribution, version control, dependency resolution, all critical. Every agent and tool gets a unique ID, author, name, version. That's key for reproducibility.
Absolutely.
They've also built in caching for performance, packaging to bundle agents with their dependencies for easy deployment.
So you can just ship the whole package.
Yeah. And streamlined processes for uploading, downloading with verification checks, and dynamically loading agents at runtime, keeping them isolated so one crashing agent doesn't bring down the whole system.
Sounds like they're bringing solid software engineering practices to agent development.
That's definitely the vibe, making it more robust, more manageable.
And how do developers actually interact with all this? Is the interface user-friendly?
They focus on that too with the client interface and auto configuration. It acts as the bridge between the application logic, the user, and the AIOS kernel. It uses a declarative approach. You define what you want, not necessarily how step by step.
Like using configuration files.
Sort of, yeah, with a builder pattern. And they have these auto classes. If you've used the transformers library from Hugging Face, it's a similar idea.
Oh, like automodel.from pre-trained?
Exactly. Like autoagent.from preloaded makes it super easy to load and use pre-built agent components with sensible defaults, but still lets you customize if you need to.
That could really lower the barrier to entry for people wanting to experiment.
That's the hope. Make building on existing work much easier.
Okay, let's talk more about the community side, the Agent Hub. You said it's like Hugging Face.
Yeah, that's the explicit inspiration. An open source distribution platform, a central spot for sharing, finding, and using agents built with the Cerebrum standard.
What kind of features does the hub have?
It lists all the shared agents, each gets its own page, secure storage for the agent components. And the landing page for each agent has version history, licensing info, their re-AD.me, source code access.
Everything you'd need to understand and use it.
Right. And importantly, direct API access via an agent chat feature plus usage instructions.
You mentioned reproducibility versioning is key there.
Absolutely. Knowing exactly which version you're using and what it depends on is crucial.
Is there any kind of vetting or quality control for agents on the hub?
That's a good point. The authors acknowledge that currently there isn't a formal vetting process. Anyone can upload.
That could be a risk.
It could, but they flag it as future work. They envision adding things like automated security scanning, performance validation, maybe even compliance checks down the line.
This seems necessary for building trust, especially if it grows.
Definitely. A necessary step for a mature ecosystem.
And related to the hub is the community agent chat, right? Tell me more about that.
Yeah, it's a public web interface, lets anyone interact in real time with agents hosted on the hub. Good for quick evaluation and testing.
How does it work? How do you talk to an agent?
It uses a simple mention system. You use the @do symbol followed by the agent's name to direct your message.
Okay, like tagging someone in chat.
Exactly. Right now, it's mainly focused on one-on-one conversations with a single agent, but the architecture is apparently designed to support multi-agent chats later.
And they've thought about stability.
Yeah, they mention rate limiting to prevent abuse and keep things stable, and it allows interaction with any agent on a remote AIOS instance via a client wrapper. Plus, it supports persistent chat histories stored locally on your device.
So it's not just about sharing the agent code, but letting people easily try them out.
Exactly. Practical experimentation, understanding what these things can do.
To really drive home the platform's capabilities, did the paper include example agent implementations?
They did. They built 4 different types of agents to showcase the flexibility. First, a basic baseline chatbot. Simple input-output mapping acts as a performance control.
Okay, the simplest case.
Second, a chain of thought agent. This one explicitly outputs its reasoning steps. Makes it easier to follow its logic and see where it might go wrong.
Useful for debugging and understanding.
Third, a react agent. This one's more dynamic. It interleaves reasoning steps, thought, with taking actions, action, and observing the results. Observation.
So it thinks, acts, observes, then thinks again.
Kind of, yeah. It models its process like a Markov decision process, learning from feedback as it goes.
More sophisticated planning. And the fourth.
A tool-augmented agent. This one demonstrates how an agent can learn to select the right external tool, figure out the parameters, execute it, and then generate a response based on the tool's output. A hierarchical decision process.
So showing off that tool layer integration, these examples definitely highlight the range Cerebrum aims to support.
Yeah, from simple chat to complex reasoning and tool use.
So wrapping up the paper's main points, what did the conclusion emphasize?
They summarize Cerebrum's key contributions: the modular architecture, the agent hub, the interactive chat. They pointed back to those example agents as proof of versatility.
And look towards the future.
Yes, they outlined future work, enhancing the hub with that vetting we discussed: security, performance validation, expanding the tool layer, maybe for multi-agent collaboration, and developing standardized benchmarks for evaluation.
Benchmarks would be really valuable for comparing agents properly.
Absolutely. And they finished by reiterating the main goal: using this open source standardized platform to speed up research and foster collaboration in the LLM agent field.
It really sounds like a comprehensive effort. Now, stepping back a bit, how does this fit into the bigger picture, the history of AI and machine learning?
Well, the idea of intelligent agents isn't new. It's been a dream in AI for decades, creating entities that can perceive, reason, act autonomously. Early AI, symbolic systems, robotics, they all laid groundwork.
But they hit limitations.
They did. Building truly flexible, adaptable agents was incredibly hard. Then came deep learning, and especially these large language models.
Missing piece.
Arguably, yes. LLMs provided this amazing ability to understand and generate nuanced language, which underpins so much complex reasoning and interaction. Cerebrum comes along at this moment, trying to provide the infrastructure needed to actually build those sophisticated agents using LLM power.
Like an operating system for agents.
That's a recurring analogy, and I think it fits well. Just like ODAs created a stable environment for software, Cerebrum aims to do that for LLM agents. We're moving from just prompting models to building systems that make decisions. Cerebrum wants to be the foundation for that shift.
Okay, distilling this down, what are the absolute key, perhaps non-obvious takeaways for someone following ML research?
I think one is just how critical standardization becomes when a field explodes like this. It's easy to overlook, but platforms like Cerebrum are trying to prevent the kind of fragmentation that can really slow down progress. Think early software without standard libraries, it was messy.
Right, the infrastructure matters.
Hugely. Second, the benefit of that modular design. It offers flexibility for researchers messing with fundamental ideas, but also lets developers build applications faster using stable components. Best of both worlds, potentially.
And the community aspect.
That's the third big one. The Agent Hub, drawing parallels with GitHub, PyPI, Hugging Face, open sharing and collaboration are accelerators. We build faster when we build together.
Don't underestimate the power of the ecosystem.
Exactly. And finally, the practical value of the interactive chat making evaluation easier. Overall, it's tackling the complexity of building these agents, memory, tools, knowledge, in a structured way.
So if this vision catches on, what are the potential real-world ripple effects? How could things change?
The impact could be pretty widespread. If Cerebrum or platforms like it succeed in standardizing things, you could see much faster adoption of advanced AI agents across industries.
Like where?
Customer service bots that are actually helpful, research assistants that can genuinely accelerate discovery, data analysis tools that are more autonomous, complex, workflow automation.
And might lower the barrier to entry.
Yeah, potentially enabling more innovation from smaller teams or even individuals, not just the giant labs, more people building sophisticated agents.
Plus the benefits for research itself.
Definitely. Better reproducibility, version control. That leads to more reliable science. And you could even imagine the Agent Hub evolving into something like an app store, but for specialized AI agents.
A marketplace for AI capabilities.
Interesting. A distinct possibility down the line.
That paints a really compelling picture. Okay, let's shift gears to our novel notions segment. Based on Cerebrum, what futuristic research ideas spring to mind?
All right, here's one building on that Agent Hub and the need for trust. What if we integrated formal verification methods?
Formal verification, like mathematical proofs about agent behavior.
Sort of, yeah. Instead of just community reviews or basic scans, imagine developers could submit formal specs, maybe using something like temporal logic, describing precisely how their agent should behave under certain conditions. The agent will never do X, or it will always eventually do Y.
And the platform can try to prove it.
Exactly. Automatically or semi-automatically verify if the agent code actually meets that specification. It's a huge research challenge, adapting these methods to LLMs, making specification user-friendly.
But the payoff could be immense.
Totally. Much higher confidence, especially for agents in critical domains, healthcare, finance, autonomous systems. Real guarantees, not just hopes.
That's a powerful idea, bringing mathematical rigor to these often unpredictable systems. What's another notion?
My second idea spins off the modularity and the hub, developing a meta agent within the Cerebrum framework.
A meta agent, an agent that manages other agents.
Precisely. Imagine you give it a high-level, complex goal. The meta agent analyzes it, breaks it down into subtasks.
And then goes shopping on the Agent Hub.
Basically, yeah. It searches the hub for specialized agents that can handle each subtask. Then it orchestrates them, manages communication, data flow between them, synthesizes their results to achieve the overall goal.
Wow, like an AI project manager building a team on the fly?
Kind of. It would need serious research into planning inter-agent communication protocols within Cerebrum, how to evaluate these composite systems.
But it could lead to incredibly adaptable general-purpose AI.
That's the potential. Systems that can tackle problems far bigger than any single agent could handle alone.
Those are some really forward-looking concepts. They definitely show how a platform like Cerebrum could be more than just a tool. It could be a launch pad for new AI paradigms.
That's the exciting part.
Well, that brings us towards the end of our deep dive today. Cerebrum really does feel like a significant move towards a more organized, more collaborative future for LLM agent development.
It's a strong attempt to build that much-needed foundation.
We definitely recommend you check out the full paper links in the description and play around with the live demos if you can. Get a feel for it yourself.
Yeah, seeing it in action helps.
And it leaves us with a final thought for you to chew on. How will standardized platforms like Cerebrum truly reshape AI innovation and its application in the coming years? What new doors open when creating and sharing intelligent agents becomes as straightforward as, say, using a standard software library?
What new possibilities emerge then?
Something to think about. Join us next time on Talk Tensors for another deep dive into the cutting edge of machine learning research.